Hi guys, welcome back to my channel. In today's tutorial, I will show you how you can leverage World Bank agricultural GDP data and create some awesome cartogram maps of agricultural GDP and agricultural GDP per capita. Alright guys, welcome back to R, where we will start off our adventure by first of all installing and then loading the packages that we need. In this tutorial, we for the first time be using a package called Pacman, which is going to allow us to install and load packages only in one line of the code. So the first thing is to install this package if it's not already available. So if if it's not already available, then we write here in this if else statement to install packages under name Pacman. And then once you have this Pacman package, what you can do is use a very convenient function from this one, which is called pload. And then here you just provide the names of the packages that you want to install and then load without double quotation marks around that. So it's going to treat them as objects. So the first package we need is the geodata package, because we'll be working here with subnational data. And the geodata package has a function which is going to get us the global administrative alliance. Now this one is not in the SF format, so we'll need to coerce, and for that purpose we'll need also the SF package. Our main file here that we'll be using is actually a raster file, and to work with raster files we need here to install and then load also Terra package. For data visualization we'll be using the ggplot2 package from the tidyverse umbrella package. And then to create breaks in our legend for ggplot2, we will also need the class int package. Last but not least is the package which will help us create one of the maps that we didn't create previously. It's called Cartogram map, which is really good with exaggerating certain parts of the country to show higher values. In today's tutorial, we will be mapping global gridded agricultural GDP, or in short AgGDP, developed by the World Bank. This is based on disaggregated national and subnational administrative statistics of agricultural GDP for 2010. And then using satellite-derived indicators, it's also fine-tuned with one of the models, which is called cross-entropy. So this is approximately on a 10 by 10 kilometers grid, and it's developed for the general agricultural GDP, but also for several aspects here, which are kind of a disaggregated types. And these are crop, fish, livestock, and forest production. Now, if you click here on the metadata, you will also see the description that I just told you. And there's also one very important thing. And it says here, there should be noted that due to limitations in available data, they have some components in output values, crop, livestock, and fishery, whereas others in value added, which is forestry and hunting. Meaning basically that there are some missing data that doesn't account completely for forestry and hunting. So this is something to keep in mind. Now, the good thing about this data set is that there are pixels, and each pixel is actually the GDP value of the agricultural production. And this is fantastic because it also allows us to calculate GDP per capita, so the agricultural GDP per capita, and then we can actually see what are the different areas of a certain country that contribute more or less to this agricultural production. So first things first is to download this. So what we will do here is we'll be using this global gridded agricultural GDP. So this is this last link. And then what you want to do next is right click here and then copy the link address. And then next thing we'll go back to R and then download this raster file, which you can see it's not very big, only 7 megabytes. Awesome. Now that you copied and pasted the link here into your editor of choice, we can go here to the end of this link, and you will notice here that the name of this file is AgGDP2010.tif. And then you can just get rid of everything after this TIFF extension, including this question mark. So you can simply delete this whole thing. And this is the URL which is going to help us download that file. So let's proclaim it a URL here, and let's put also double quotation marks around it. And then also let's fetch the file name directly from this URL. So basically we can just say here base name URL, and then we can use download file from base R, where we need to provide first of all the name of the URL. The second one is the destination file name, which is also dest file. And then the final thing is to set the modes. We'll be using the binary mode for downloading this file. As we said, this file is very, very small, so it's only 7 megabytes, and we can go ahead and load it directly into R. I will load it and attach it to this object called AgGDP_data, and we'll be using Terra Rust to load this raster file. So here we simply pass this test file, which is then going to load this into R. And then once we actually do that, we can quickly inspect this newly loaded file. So I'm just going to inspect it like here. And you can see that it's a raster file. So this is a global one. As we said, the resolution is quite coarse in a sense that, the dimensions are very, very small here. So it's not going to be problem cropping or doing anything. You will also notice here that the base coordinates reference system is the WGS84. That's very important. And here you can see minimum and maximum values. So they go from 0, of course, because the GDP cannot be negative. And then this goes to the maximum value, which is in USD dollars or 2010 level. Once we have the data, we can also load the subnational boundaries, and in this tutorial we'll be working with the subnational boundaries of Brazil, which is one of the major agricultural producers in the world. So let's actually call this one simply country, and then let's use geodata. And as I said before, geodata has a very convenient function which is called GADM, and GADM is simply an acronym for Global Administrative Boundaries. So here you need to specify the country name, and you can simply go with the ISO2 code for Brazil, which is simply BR. Then you can choose the level. Here I'm just going to choose the next level, subnational level of Brazil. And finally, you need also to provide the path. So this is where this file is going to be saved. So it's saved locally, and simply I'm saying here, save it to my currently working directory. Now this is not going to be in the SF format, so we will need to coerce this into SF format, and this is where the SF package kicks in. So here we simply say st as SF, which is going to coerce this into an SF object. Now, one thing that can be very useful and interesting to calculate and visualize here is what is the agricultural GDP for each of the Brazilian regions. And for that purpose, we can utilize the zonal statistics, which is going to help us do exactly that. Luckily for us, Terra also has a function which is called zonal, and it's going to help us do this. So let's calculate this, and first of all, create a new object, and then from Terra use or call this zonal. Now this one requires several arguments. The first one is the X argument. So this is the raster file that you're going to be using. So AgGDP_data. The second one is Z. So this is the vector formats. So here we need to again coerce this one into Terra vect, and then use country. And then the third argument is actually the function that you want to apply. So remember that each pixel is the independent value, suggesting that that pixel produces that much of agricultural value. So that means that we need to sum up all the pixels that fall within a certain region. So our function is going to be sum. And because there's also missing data here, we also want to simply ignore that missing data. So here we're just going to be saying that we want to remove if there is any data like that. All right, and then once you actually run this, you can inspect. So this is now going to be a data frame. So we're going to be inspecting this data frame here. So AgGDP subnational, and I'm just going to move this up a bit and then show you here. So here are the first 6 values. Of course, this was calculated for all the Brazilian regions in their order of appearance in that subnational shapefile. So what we can do next is simply merge or join this one to that SF one, and then simply do the plotting. Okay, so in this section we will merge the results back to the subnational shapefile, and then we'll be creating the cartogram before putting it into our visual. So let's first of all merge. So let's create country AgGDP subnational, and then over here we can simply do the column the cbind. And for that, we first need to pass the country, of course, with a subnational boundaries shapefile. And then the next one is these newly created AgGDP_subnational. Now, the next thing is to do the cartogram. And before actually we jump straight into it, I would like to actually show you how you can get the coordinates reference system for Brazil, but also for any specific country. You can easily determine coordinates reference system for any country in the world using this website, which is epsg.io. And the reason why I'm here is that I get a lot of questions. How do I define the coordinates reference system for a specific country? So here is how you do it. First of all, here you type the name of the country, then you type here search, and I get for Brazil a number of them. So the easiest bet is actually to go to the first one on this list, because usually you're going to get a list of a lot of them. And I also checked this is the official coordinates reference system for Brazil. So that's fine. So you click on this first one, and then you get here a bunch of information which might confuse you. But what you need to do here is you need to scroll down, and then you need to click here on the proj.4. So this is going to give you a text of your coordinates reference system, which can be used in R. What you need to do is simply click here on copy text, and then we will go to R and define, and later on use this coordinates reference system. Well then guys, we pasted here the coordinates reference system for Brazil, and the reason why we did that is twofold. First of all, we want to represent Brazil as best as possible, as most precise as possible. And second one, Cartogram does not work well also with WGS84 coordinates reference system. So for transforming into a cartogram, we will need to use something else, and this one will definitely work. If it doesn't work, you can simply convert into some other, let's say, metric coordinates reference system. Anyways, for now, what we will do here is we're going to pass this into object called CRS, and then we're going to put double quotation marks at the beginning and at the end of this one so it can be used in R. The second thing is we will be transforming our object previously created, country AgGDP subnational, into this coordinates reference system. And for that, we can use st_transform from the SF package. We simply need to state here that CRS equals CRS. And then in the next one, we'll be creating cartogram. Is actually what we'll be doing is we'll be preserving the regional lines, and we are not going to be setting them apart, but they're going to become distorted, and they're going to be distorted and they're going to gain in size based, of course, on the value of the agricultural GDP. So it's going to look like a very much of a fat map. Anyways, so we're going to pass this to the pipe, into the pipe, and then from cartogram, we'll be using cartogram cons to create that type of a map. So over here, since we're putting this into a pipe, we don't need to provide this input SF file because it's already there, but we do need to provide the name of the column, and the value column is called alloc, so we simply inherit it. I didn't change it. And the second one, the second argument is the number of iterations. So this one can be tricky. The default one is 15. I put it to 5 samples or 5 tries, 5 iterations, but maybe you can even decrease it further. So this is actually a very expensive operation, and even this lowered one, it's going to take maybe even up to like a minute. So it's really advisable to decrease this from 15, definitely. So you can play with this one. And once you actually run this, you will see and explore, of course, this object, you will see that this is still an SF format. So it's an SF format. It has here, though, a different coordinates reference system, but it's still an SF format, and that's something we need to take into account when working next with ggplot2. We'll have to take 3 steps before we jump on to creating the map. The first one is to define the legend breaks, the second one, colors based on them, and finally to create our ggplot2 theme. Let's start off with breaks. First things first, I would like to actually create a new column, which is going to be normalizing this existing one, because I noticed that the values of the agricultural GDP for Brazil or different states are really humongous. So let's go ahead here and let's use this newly created object, and then let's simply create a new version of this alloc column, and this one is simply going to here be created by dividing this by 1 million. So let's just see if we have 6. Yes, we do have 6, and then we can jump on to creating the breaks. So for the breaks, I like to use the class int package because it provides you the possibility to create nice breaks based on the normal intervals, natural intervals, sorry. So what we need to provide here is the name of the column and of course the name of the data where it comes from. So it can be data frame, it can be an SF object, it doesn't matter. Then here a number of breaks that we want to create. I usually go for 4 to 6 breaks. And then here is the style. So this one has a lot of different styles and we're just going to go for the equal here, but I think Jenks is even better because it provides like a very nice distribution here, but we're going to go for this one. You can here check that there are so many other ones as well, depending of course on your choice. And then the final thing here is to simply grab these breaks from this object. All right, once we have this, one more thing which is also pretty cool to do is to define the limits of your plot so that you include both the minimum and the maximum values in your map. The way we do that, define the limits, is simply take the minimum and then also the maximum value of this column that we previously also used here to create these natural intervals. Then one very important thing here while you're doing that is making sure if there are any missing values to simply remove them. So what I'm going to do here is simply say that we don't need any values, or that they are actually going to be discarded in case there are any. Okay, so once we have the breaks, we have the limits, we can go ahead and also define the colors of our plot. And why did I say that the colors are based on the breaks? Well, exactly because the number of colors is going to correspond to the number of breaks. And for the colors, we can use HCL colors, which we used in some of the previous tutorials as well. So this is base R. Here we need to define the number of course, the color values. And here we can simply say that it's going to depend on the number of the elements of the breaks. As simple as that. And the second thing that we need to do here is the palette. So the palette, there are numerous palettes here. I'm just going to go for the weirdest one, which is kind of widely used, and it's also more or less pretty, I think also corresponds to the topic here. Now, apart from this, we can also define whether we want a reverse. Yes, we do want a reverse one palette because we want the lighter colors to be associated with lower values and darker colors to be associated with higher values of agricultural GDP. Okay, and then we are here at the third step, defining the ggplot2 theme. So it means how the map is going to look like, everything around the map. And I'm going to create here powerful theme for the win. And it's going to be a function which we're going to be basically calling within ggplot2. So first of all, I'm going to here use theme void, which means I'm going to get rid of any excess elements around this plot. So that's the first thing. The second thing is to then use theme here to specify further what we mean by this. Okay, so what do we mean by this? Well, we can specify several things. One of them, a very convenient one, is the legend position. So this is where your legend is going to be. And the easiest thing is to simply put it on the top, but you can also play with different sizes of it. Then the second thing we can define is, for example, legend title. And legend title is a text, and you need to tell, of course, ggplot2 that it's text, and that's why you're using here element text. Now, within the brackets of this one, you can define, for example, the size, which can be 11 pixels. You can define the color, for example, charcoal gray or anything else that you want. It doesn't really matter in this specific context. Apart from this, you can also define legends, the text of your legend as well. So I'm just gonna paste this one here. I'm gonna go for a bit smaller size of the text compared to the title. And one also very convenient thing is you can basically shrink the margins around your map, meaning you can shrink that white space. The way you do that is by manipulating the four sides of the plot, of course. Now the top side, we might assign it a bit more space, and that's why here it's a positive value. So I'm going to give it a bit more space, but I am going to actually shrink the space for all the other sides, the right, bottom, and then also the left side. So the minus value here indicates that we are shrinking the space, And again, the positive value of 0.25 means that we are expanding this space. We have all the ingredients for the soup, and we are finally ready to create the cartogram map of agricultural GDP for Brazil on the subnational level. So let's call this object map, and let's use actually lowercase. So let's call it map. Let's call then ggplot function. And then our one and only layer is going to be an SF object. So that's why we need to use here geom_sf function or attribute within ggplot2. Now for the data, we are going to use, of course, the one that we previously created, and we did all the modifications. And then once you have this, you need to define the main aesthetics. And the main aesthetics for our case is, of course, the fill, because we want to fill the colors of the polygon. So here we can simply use this alloc million that we previously created. So this is a normalized version of this main value. So we're now talking about millions of US dollars. And then here for the color, we can choose the color, of course, of those administrative boundaries. And you can maybe also choose here to have the same color, but we are going to go, for example, for, let's say, white. And then we can also choose here the size of that line, of course, how thick it's going to be. Let's say, for example, 0.2. You can also increase to make it thicker. You can also decrease to make it thinner. It's totally up to you. Once we define this, we can go ahead with customization. And one of the first things that we want to customize here is the color. So we want to customize actually the color and the legend. So for that purpose, we'll be using here scale fill gradient. The reason why I put in here fill is that because our main aesthetic is also fill. So here you can, for example, define the title of your legend. So you can, for example, put here USD, which means US dollars, and then USD, for example, millions. Then we can also pass the colors. The colors are the option calls that we previously created. We can also pass the breaks. Now the breaks are also the object called breaks. We also have the limits, making sure that we are in the range of the possible values. And then also we want to put labels to our legend. And here we want to also get rid of any decimals that are a byproduct of dividing the main value by 1 million. So I'm just going to round them here using round from base R. And the round works in a similar way like round in SQL as well. So here you need to pass the object breaks and then the number of decimal places that you want to keep. So we don't want to keep any. And one of the final steps here is to also decide what is going to be the NA value color, and I'll say let's go for white, since the white is the color already of our regional boundaries. Okay, we can also go ahead and further customize the legends, and the way to do that is using guides argument in ggplot2. Now, because our main aesthetic is fill, we also need to use here and say that it is fill. And because we have continuous values, we need the guide color bar or a legend for continuous measures. So over here, you can define several things. First of all, you can define the direction of your legend. Let's say, for example, we want our legend to be horizontal. You can also make it vertical. So these are the two options. The second thing is that you can define the heights. So it's called bar heights and also bar width of your legend. So over here, you can define in terms of units, which can be millimeters or centimeters. And because we're having horizontal one, we want this one to be thin. So I'm going to put here that we're going to have 1.5 millimeters. But because we have still big values, I would like to use a bit wider one. So I'm going to go here for actually 10 centimeters, which sounds really big, but you will see once we start plotting this. Okay, so there are also some other things that you can define. Of course, one of them is where is the position of your title. So the position of the title can be, for example, at the top. You can also define the positions of the legend text. So that one can be on the bottom, so below the legend itself. And you can also define, for example, title horizontal justification. It can be, for example, 0.1, so this is mid-centered. And you can do, for example, the same for the label position. also making it centered. So also 0.5. So these are some of the options that you can do. You can also here define that we're going to have only one row. And one also important thing is that you also want to have here those legend keys next to each other. So you here need to pass them by row equals true. So those are some of the things that you can pass to the guides argument. There are more, but those are the main ones. Now, one important thing here is to also pass the coordinates reference system that we are using. And this one is, as we previously seen, called CRS. Okay. And then in the labs arguments, you can specify things like, for example, title. So you can have a title. We can, for example, use, I don't know, agricultural GDP for Brazil, something like that. You can also specify other things. For example, if you want a caption behind it, you can also have caption. We don't need a caption at the moment, so we're just gonna leave it empty. And yeah, so those are the things. And before we wrap this up, the only thing we need is to of course, use our theme for the win, which we previously created. Okay, perfect. So we created the agricultural GDP map of Brazil, but sometimes it's more informative to get the GDP per capita map. So in this tutorial, I will show you how you can easily do that, not just for Brazil, for any other country. And the method or the approach we're going to be taking is similar to what we did in one of the previous tutorials on mapping CO2 emissions per capita. So in that sense, we'll be using pretty much the same data set, population data set, but we'll be using not for 2020, but 2010, since the agricultural GDP estimates are based on that year. So anyways, this is the link. I will be providing it also in the description box below, together with the description of this tutorial. But for now, what we're going to do here is simply declare this as U or URL, and then put double quotation marks around it so that we can download. So that's the first thing. The second thing is to fetch the name, of course, of that file. And here you will notice that this file that we will be downloading is a zipped file. So we'll need to unzip once we download. And to download, we'll be using the same approach as we did with the AgGDP file. So for the URL here, we define here U. Then for the destination file, we'll be using the file name. And then finally, for the mode, we'll be using the binary mode for downloading. Once you download this, so the zip file is going to be around 450 something megabytes because it's a global extent. Then you can go ahead and unzip this file name once more. And then in order to load this one, now we do have the raster file or TIFF format. We'll need to actually get rid of that zip extension in this file name, add the TIFF extension, and then load it into R. So let's actually call this raster name. And then let's use gsub from base R to do this replacement. So first of all, we're going to be getting rid of this zip extension. We're going to be adding the TIFF extension, and we're going to be adding all of this to this file name string. And then finally, we can use Terra and Terra Rust to load this file. So we simply write here Terra Rust and then pass here this raster name. Okay, so that's the first step, where we actually download, unzip, and then load this population raster. So this is a global extent. Of course, for Brazil, we can just do now zonal statistics to sum up all the pixels, where each pixel is some number of people, to get the population estimates for each Brazilian state. So we'll be basically doing the same what we did before, but just with agricultural GDP. So we'll be using here Terra, and then Terra zonal, and then we'll be defining two arguments here, or actually three arguments. So Terra zonal, and then over here for the X argument, this time we'll be taking this pop raster file. For the Z argument, again, we'll be using, of course, the country SF file, but coerced here to the Terra vector format. Then in terms of the function, we are again using the sum function because we are summing up the pixel numbers, pixel values. And finally, we can also ignore any missing values if there are. And once you do that, you will again get a data frame. So what we want is to explore the first few rows to see what's going on. So I'm now I'm going to just show you how the first few rows look like. So here we get the estimates. So these are the first 6 rows. There are obviously more. And these are the population estimates. So what we need to do next, now that we have the information on the agricultural GDP for each state, on the population for each state, then the next thing is, of course, to put this together. Now, one thing that you probably notice from this data frame is that the column name inherits the name of the raster file, which is very long and it doesn't make sense for the purpose of this tutorial. So we can simply change the names of one and only column here, and we can simply call it, for example, population. So we can call it population here. Okay, so once we did that, again, the next step now is to put together the agricultural GDP and the population estimates, and then calculate the agricultural GDP per capita. And this is what we're going to be doing in this step. So I'm going to be creating this object, and this object is going to bind together the 2 data sets. So the first one is that the one that we first created, so the country AgGDP subnational, that's the first one. And the second one is this newly created, this POP subnational. So those are the 2 ones. And once we actually merge them together, then the next step is to create this AgGDP per capita measure. So we simply can take this one, and then we can just create AgGDP per capita. And the way to do that is very straightforward now that we have both the agricultural GDP and the population estimate. So what we're going to do here is simply use that first one and then divide the GDP by the population so that we get finally what we need. Okay, so let me just also grab the population as well. Okay, now once we actually have this, once we have this field, we are actually going to be able to do cartogram once more. But again, we need to go through that process where we actually run the cartogram. So we create another cartogram, because now we are basically, what we did was we created another column and we need to account for that. So here we can just use and create a new one, a new object. So for the per capita one, but we're going to go through the same process here, in a sense that we will be, first of all, we'll be transforming this one into the Brazil's coordinates reference system. So again, we need to use here st transform, and then just pass here that our CRS is called CRS. Then we go down the pipe again, and then we again call here cartogram, and from cartogram we call this cartogram cons that we used also before. Okay, and then within this one we now specify this new column. So this one newly created AgGDP per capita. And then also you can specify the maximum number of iterations. Let's say I'm going to take 5. But again, if you want to really speed up this process, you should definitely lower this number. Okay, so then the last step that we want to do here is, before of course mapping, is of course to create another, breaks, limits, and everything else. So I'm just going to go actually back here and then just copy basically this part where we create breaks and colors for what we need. So we're just going to stick with the same one, but what we need to change here, so starting here from this breaks part, what we need to change is the following. We actually need to take this one, so country AgGDP percentage, because that's the data frame, and then we're going to be using this AgGDP underscore PC, and then using that, of course, we actually transformed that one. So we're going to be using this one, AgGDP underscore PC underscore cont. So that's the one, because this is the cartogram one. This is the one that has the information. So over here, we're just going to be replacing this, and then also replacing the column name, which is AgGDP PC. So over here. So we need to do this for the breaks, also for the limits, both of these. And then also here, we don't need to do anything about the colors. Anyways, so we just need to actually run this whole thing, which is going to create us then, a cartogram and everything else that we need. Now, once we actually have that, then the next step is to create a map. And for map, again, we don't actually need to reinvent the wheel. What we can do is we can simply take this chunk that we used previously and just make some smaller adjustments. So we can just go back here. These smaller adjustments are the following. Well, first of all, this can be called, let's say, map 2, if you want to save it afterwards. Then colors and limits and breaks stays the same, but this does not stay the same. So we're going to be using a different SF object here. It's called like this now. So AgGDP per capita, of course. And then the second difference here is that we're going to be using the per capita now, per capita column. USD are not millions anymore, so it's simply US dollars, so that's fine. And then here CRS, and finally here for the title, it's simply GDP per capita for Brazil. So the thing for the win stays, and the only thing now that you need to do is simply run this whole chunk, and this should give you a bit different map from the previous one because now we accounted also for the population. And this is how you leverage agricultural GDP data to create some awesome maps. Guys, I'm really looking forward to your own projects and how you can take this tutorial to some other countries. But if you're interested in replicating today's analysis, I prepared the link to the GitHub repo in the description box below together with some other links, so do check it out. Feel free to clone it, modify it, reuse it as you see fit. If you have any questions, comments, or just general feedback, feel free to reach out to me here on YouTube, but also on Instagram and X. If you're new to R and you seek to expand your data visualization and geospatial knowledge with R, I prepared a few cool tutorials for you, so do check them out. See you next time.